Today, we'll follow a team of scientists on a unique expedition to the Amazonian rainforest. They're on the hunt to discover some of the weirdest creatures and wildlife. Tiny insects of infinite complexity and curious design. Our Homo sapiens ancestors have explored all of the continents since our arrival on Earth, some 150,000 years ago. Yet what you are watching is a species greatly unknown that has been highly magnified. These are the aliens of the Amazon. Welcome to the miniature and secret world of Membrosidae, more commonly known as tree hoppers. This alkisme is one of 3,000 identified tree hoppers that are particularly difficult to find. The large majority hide deep beneath the lungs of our planet in the Amazonian jungle. Filmed for the very first time under the environmental scanning electron microscope, we were able to view them under a new dimension. Hairs look like trees, and cavities look like craters. But just how do these creatures live? What is the use of their superstructure? What role do they play in the ecosystem of the tropical rainforest? To find out, we must journey to the Amazon with research scientist Stuart McCamey. Stuart McCamey is a USDA World Authority on tree hoppers. Today he is leading a team of 6 world experts deep into the Ecuadorian jungle to study these mysterious animals. They're working in the heart of the National Park of Yasuni, classified a biosphere reserve by UNESCO. It is roughly 180 miles east of Quito, the capital of Ecuador. To survive 40 million years, from generation to generation, tree hoppers have developed highly efficient strategies, physical adaptations like camouflage and escape, but equally as important, maternal care, alliances with other species, and communication.
There have been lots of species that have probably evolved and gone extinct that we'll never have a chance to do, but by investigating this, which is a pretty large group of insects that are under our noses without us even knowing it usually, it helps complete the picture of what's going on in our world and how these ecosystems work.
After the first night at camp, Stuart is impatient to exercise his sharp, trained eye.
This is great. The first morning, and Bosidium, we barely know anything about them, but boy, I never expected to get so lucky the first time.
This is what Stuart is so excited about. Bosidium, a rare solitary tree hopper of striking appearance. Evolution has produced a live piece of contemporary art whose ancestors have lived here for over 40 million years. Their large globular eyes are dominated by various numbers of hairy inflated bulbs carried on their backs. These bulbs come in a range of sizes and shapes. Like 90% of tree hoppers, Bosidium can only be found in the northern countries of South America, which is why Stuart McCamey and his team chose the Amazon to set up camp.
Suck it in, and then we can bring it back to the lab and study their behavior. We really are coming looking for the unexpected. So by its very nature, we don't know what we're going to find. And that's the exciting part about it. there's so many different shapes of tree hoppers, literally, that you just have to look for any irregularity in the plant to find them.
When it comes to disguise, many tree hoppers are masters of the arts, especially as they spend most of their time sitting still, feeding on plants. In order to survive, evolution has developed various strategies. Strategy of evolution number 1, camouflage. This Symbomorpha nymph perfectly imitates a green leaf. A solitary Tolania is hidden on the left-hand side of this branch. Can you spot it? To appear as another living organism in order to avoid predators is what we call mimicry. With their brownish colors, Stegaspis look rather similar to a dry leaf. Tree hoppers range in size from 25 millimeters to 2 millimeters, the size of a walnut down to that of a pinhead. These are not tree hoppers spread out upon the top of this leaf, but tiny feces. Imitating them and hiding beneath the leaves is a tree hopper Bulbinota. Others give the impression that they are ants, or just thorns on the side of a bush. It takes the eye of an expert to find them.
There he is. So you can see him walking through the leaf. See him?
You have it?
What's that?
He's gonna jump. Using it.
No, I can do this. Got him. Well, I found that there's a lot of tree hoppers around here. They're really hard to find. You know, you gotta keep your eyes open. You can't blink, or you're gonna miss them. And I've missed a few already. And they're faster than you think.
To escape from Nick or other predators, tree hoppers have 2 pairs of eyes. Ocellus eyes in the center that do not form images. These simply sense light and dark. On each side are a pair of complex compound eyes.
The compound eyes are made up of hundreds of facets. And no one really knows if they see multiple images or if their brain processes all those images into one, like our brain processes the images from 2 eyes into one image.
Obviously, their eyesight is good enough when you try and catch them.
Right, they're fast.
It's the very first time the team has viewed their subject of research with such high magnification and details. This incites them to come up with new theories.
Oh, wow, that is. Those are the city at the top.
That is awesome.
Beautiful.
Yeah, I wonder what it's mimicking.
Yeah.
I think it's mimicking fungus.
The fungus that attacks ants and things like that?
Yeah.
Oh, maybe.
Nick is referring to the deadly cordyceps, a fungus that enters insects through their breathing holes, spreading through the body of its victim until it dies.
A lot of the tree hoppers are spitting images for this, so it's possible and quite probable that at least some of these are mimicking dead, rotting insects, which would be unpalatable.
These tree hoppers have mastered the art of camouflage so well that they look like a completely different organism. Using mimicry, they trick predators and survive. Strategy of evolution number 2, be equipped for escape. Like all insects, tree hoppers have 3 pairs of articulated legs. They use them to walk with or to jump in order to flee from danger. Once adult, they have 2 pairs of wings. They cannot travel far with these, but are able to escape within a fraction of a second. And their wings can take them to the summit of the canopy. Stuart Stuart believes the same kind of tree hoppers are found at the canopy level as down below, and he's challenged evolutionary biologist Nick Tatarnik and expedition photographer Patrick Langman to find them.
So you reckon we're going to climb that?
I think that we can climb up using the other trees around. But
Yeah, because that's about 20, 30 meters. I don't know how high you can throw, but I sure can't. Now, you know what? You go first.
The rainforest holds unexpected obstacles for these field researchers.
It doesn't look as tall from here.
As they begin their new adventure, success is far from certain.